Okay, so I want to start us off with a quick puzzle. Now, on the surface, it seems super simple, but it actually reveals this fundamental trap in our thinking that honestly almost everyone falls into. Here it is, the numbers 2, 4, 6 follow a simple rule. So your job is to figure out what that rule is. Just what's the first thing that pops into your head? What's your gut hypothesis? All right, so to figure this out, you can propose other sets of 3 numbers, and I'll tell you if they fit the rule or not. So, what numbers would you test? Think about it for a second. What sequence is going to give you the most bang for your buck, the most information? Now, this isn't just some random brain teaser. No. This is actually the core of a brilliant psychology experiment from back in 1960, one that exposed this really deep-seated flaw in how pretty much all of us think. So what did you come up with? If you're like the vast majority of people, your first thought was probably something like, oh, it's even numbers. Or maybe more specific, like numbers that are increasing by 2. I mean, it's the most obvious pattern, right? And this is where it gets interesting, because this perfectly illustrates our first instinct. To test that increasing by 2 idea, you'd probably throw out a sequence like, 8, 10, 12. And if I were running the experiment, I'd say, yep, those numbers absolutely conform to the rule.
Okay, so you're feeling pretty good now, right? Your hypothesis is looking solid. So you try again, just to be sure. You might test, say, 20, 22, 24. And guess what? I'd say, yes, those numbers also fit the rule.
All right, so after a couple of tests that come back positive, the conclusion feels like a slam dunk. You've confirmed your theory not once but twice. You'd confidently say, the rule is numbers increasing by 2. And you would be completely wrong. So, what in the world is going on here? Well, this was the exact setup that the psychologist P.C. Watson used in his 1960 paper, which was called On the Failure to Eliminate Hypotheses. He really wanted to get to the bottom of how people test their own beliefs. And look, this wasn't just a thought experiment. The subjects in his study, 29 university students by the way, they were given a record sheet that looked just like this one. They had to write down the numbers they were testing, why they were testing them, and of course, the feedback they got. This gave Wason a front row seat to their thought process. So, what is the actual rule? After seeing just how many people get this wrong, you might be thinking it's some crazy complex thing, but the truth is actually the exact opposite. The correct rule was simply any 3 numbers in increasing order. That's it. That's the whole thing. So yeah, 2, 4, 6 works, 8, 10, 12 works. But you know what else works? 1, 2, 3. Or 10, 20, 500. Even -5, 0, and 10. The rule was way broader than almost anyone guessed. And what's really wild is just how hard this was for people. Get this, out of 29 highly intelligent university students, only 6 of them figured out the correct rule on their first try. Just 6. Which really begs the question, right? Why would a rule this simple be so incredibly hard to find? And the answer? Well, it gets to the very heart of how we fool ourselves every single day. Wason's experiment gave us a name for this powerful mental flaw, the confirmation trap. You've probably heard of it as confirmation bias. It's our natural, deep-seated tendency to look for evidence that proves we're right, instead of looking for evidence that might prove we're wrong. Okay, so here's the crucial idea. There are basically 2 ways to think about a problem like this. The first way, the one most of us jump to, is called confirming or enumerative thinking. You come up with a theory, and then you only test examples that you expect to work. The other way, the much more powerful way, is falsifying or eliminative thinking. This is where you actively try to break your own rule. You ask, how could I be wrong? And the data from Watson's paper on this, is crystal clear. He actually created an index to measure how often his subjects were trying to eliminate their ideas versus just trying to confirm them. And look at this. The successful subjects, the ones who got it right, had a score of 1.79. The unsuccessful subjects, a measly 0.24. I mean, that is a huge difference. Let me put that another way. The people who actually solved the puzzle didn't waste their time testing 8, 10, 12. No, they tested something that would break their initial rule. They test something like 1, 2, 3. See, if their rule was increasing by 2, that sequence should fail. So when the experimenter says, yep, 1, 2, 3 works, it instantly tells them their hypothesis is wrong. Or they test something like 3, 2, 1, which would fail, and that failure would tell them that increasing order must be part of the real rule. So why should we care about a 60-year-old experiment today? Because this bias isn't just about number games, not at all. It affects everything, our personal beliefs, scientific research, even huge business decisions. Learning how to overcome it, it's like having a cognitive superpower. As Watson himself put it right there in the paper, just collecting examples that fit your theory is a really dangerous way to search for the truth. And why is it dangerous? Because, as this whole puzzle shows, tons of different, even wrong, hypotheses can be supported by the same confirming evidence. So, what's the big takeaway here? How do we actually use this? It boils down to a simple 3-step mental habit. First, just be aware of your initial belief. Recognize it. Second, flip the question. Instead of asking, how can I prove this is right, ask yourself, how could this be wrong? And third, you have to actively go looking for that disproving evidence. That's where the real learning happens.
And that really leaves us with a final and maybe a little uncomfortable thought for you. Think about your own life, your work, your relationships, your most deeply held convictions. What is one really important belief you hold that you have never, ever actively tried to disprove?